Okay, welcome. And today we're going to talk about more about an application. This is going to be talking about things that we come through, like if you work in the trades or you work in manufacturing, or most things where things are being created, constructed. You have to deal with what's called tolerances. Okay, so when you manufacture something, whatever the widget is, whether it's air condensers, union pipes for oil piping, or anything like that, when you look at the blueprint will have specifications. And in these specifications will also include what we call tolerances. Okay, so there's a specific measurement for something. Let's say you're talking about a pipe and you're looking at the OD, the outside diameter of a pipe, right? Well, on the blueprint for that pipe, it's going to give a measurement of what the outside diameter should be, okay? But then it's going to have a tolerance, because in manufacturing, just like most natural processes that we come across, there's going to be variation, natural variation in the process. Machines do not create the pipe or the widget the exact same way every single time, right? That's just impossible, okay? Just like if you look at bottles of beer or bottles of soda, you know, they have the net weight of volume of the liquid in the bottle. Well, that doesn't mean that 12 ounces, if it states 12 ounces, that doesn't mean that 12 ounces of Coke or soda is in every single can or bottle, right? So there's natural variation. Well, what we say is okay, so on the blueprint, it'll have a specification, it'll have a specific measurement for that dimension, but then it's also going to include a tolerance which says, hey, this is the variation that we're willing to accept, okay? And so usually there's a plus minus that goes along with that, because you could be high or you could be low, okay? So, for example, we look at the tolerance. So the tolerance is that natural variation. Okay, so tolerance is how, the variation that we can be from the blueprint specification, right? So if we're looking at blueprints, and we're looking at the blueprint specification, the tolerance is going to be that variation from the specification that's acceptable. Okay? And it's, let's say, for example, we're given plus or minus 0.05. Okay, so now, again, this plus or minus is telling us, hey, we could be 0.05 above what's specified or 0.05 below what's specified. And also the plus minus is telling us also the operations that we're going to do, right? That we're going to perform, subtraction and addition. Okay, so that's what the tolerance means. Okay, now the limit dimensions. Okay, the limit dimensions is what we get when we actually do the adding and subtracting. Okay, so if we take the specifications, and we actually do the adding and subtracting of our tolerance, then we're going to get the limit dimensions, and the limit dimensions are going to be the high and the low, right? So we're going to have the low limit dimension high. And so the limit dimensions is going to be, hey, what's the lowest acceptable measurement? And what's the highest acceptable dimension? So for example, going back to my example of the outside diameter of a pipe, okay? Well, let's say you're working in manufacturing, right? And you're on the line and you're running this machine that's creating these pipes. Let's say it's a CNC machine or a lathe, and you're drilling out these pipes. And so what happens? What? For quality control, you're going to have to stop the machine typically every hour, and you're going to have to measure a certain number of parts, whatever engineering or quality assurance has decided. Okay, so you're going to have to measure these outside diameters, let's say, of these pipes. Let's say you have to choose 10 pipes, and you're going to have to measure the outside diameter. Well, what you're doing is you're going to have a certain limit dimensions that you're going to have to check against. And so if your measurements, if any of your measurements fall outside this range, then what we say is that that part is a non-conforming part, or that dimension is out of tolerance, okay? Which means that typically it's unacceptable, okay? So, and that's where quality assurance comes in, right? Because what happens if you have a ball bearing that is outside of tolerance? Well, what happens if it's too small? Well, it could fall out, right? And in certain situations, ball bearings falling out of where they should be is not a good thing. Or if it's too big, it's not going to fit. And maybe you're going to have more friction, which is, again, more friction is not always a good thing. Okay, so that's why these are important. Okay, so what's an example? Well, let's do an example involving this sort of thing. So let's say we have an object on a blueprint, and it has a specification of 8.097 inches, plus or minus 0.005 of an inch. And this is typically the way it would be written on a blueprint. Okay? So again, this is the specification, this is the tolerance. And so typically it would be written on the blueprint next to the description of the dimension, right? So it would be, this is the specification, 8.097 inches with a tolerance of 0.005, 0.005, and plus or minus. So we want to find the limit the limit dimensions. Okay, well, what are we going to do? Well, we're going to do exactly what this tells us to do. We're going to add and subtract. Okay, if we subtract 0.005 from the specification, then that's going to give us our lower limit, right? And then if we add 0.005, that's going to give us our upper limit. Okay, so let's do it. So if I subtract 0.005, right? So if I subtract 0.005, I get what? I get 8.092. And if I add 0.005, I get 8.102. And these are, of course, in inches. And so what's the limit dimensions? Well, here they are. So that means that the lowest acceptable value, okay, for this part or this dimension is 8.092 inches, and the largest acceptable measurement for this dimension is 8.102 inches. And so this gives us our range of acceptable values. Anything outside this range is unacceptable, or in other words, out of tolerance. Okay, that's it. Have a great day.